Uh, Good afternoon, my friends. Let's start the first chapter in this course. This chapter is actually mainly math and introduction. It's not, like a main topic for the physics. It's just gonna be review what skills we needed for this course. So we're gonna throw some lights on that stuff. Okay. Next week we're gonna start the first chapter of the motion. So it will be the official physics, and I believe next week or at the end of this week. So this chapter will be introduction and the nature of science and physics. Let me, friends, start with this picture. So, who think that physics is really a tough subject? Oh, really? I thought it's really easy. Okay, so I'm gonna start from right toward left. And if you think that physics is really tough, please raise your hand. Okay, why physics is really tough?
I've taken it before.
You think, okay,
I just couldn't understand.
okay.
It
So,
was hard. I studied, I practiced, I just couldn't understand how to, math-wise, I just,
is it math?
yeah.
Okay. So you think that it was hard because of math? Am I right or not?
Just that physics part.
Of the
solving
concepts?
it. Yeah.
Okay. So do you agree with me that if you asked me, Mahmoud, can you drive this big truck? Can you drive it, Mahmoud? I'm gonna say no. It's really hard. It's really tough. Make sense? But if I got the skills how to drive this big truck, do you think I'm gonna drive it or not?
If you have the skills.
Yeah, if I got the skills, yeah, someone taught me how to drive it and so on.
Mm-hmm.
So I believe it will be easy for me to drive it. Am I right?
Mm-hmm.
Okay, maybe I'm not professional like someone else, but I can at least drive this truck, big truck. Agree with me?
Mm-hmm.
So it's skills. So you have to focus on skills to go through physics. Make sense?
Mm-hmm.
Okay, awesome. Perfect. Did I answer your question?
Mm-hmm.
Okay. Yep. You said
I haven't taken it before, but I heard it's pretty hard.
you hear that?
That's hard.
Yeah, me too. I heard it's really hard. Believe me, I came here the first day here in U.S. Minnesota. I was in a Holiday Inn. It was close to U of M, and I tried to make friendship with others. And once I said that I am professor in physics, they said like that. So why that this reaction? Okay. Then I realized that he thought that physics is a really tough subject. Okay. But actually it's really easy. Very, very easy. Okay. It's like anything hard, but once you got the skill, so for sure it will be really, really easy. In my opinion, it is really easy, and we will see together that physics is really, really easy, very, very simple. Okay? And if you think that physics is really tough because it's physics, yeah, call it Physik in Germany. It's Physik, سهلة, or easy, okay? In Arabic, it's physia, so it's really easy, okay? So don't call it physics, okay? So just take it like easy subject, okay? Don't be like get tension from the physics. No, it's way easier than that. Okay, perfect. Who think that physics is tough subject? Raise your hand. Okay, perfect. Let me go there. Okay, first. Why physics is tough subject? In your opinion?
It's going to be tough for me because I think there's a lot of math involved.
Math,
I
okay,
think there's a lot of formulas that you have to memorize.
okay.
So I'm worried about that a little bit.
Okay, so 2 points here. Math and too much formula to memorize. Awesome. Let me answer the first point, math. Here I realized here that math is taken as steps. So this is step 1, I have to go to step 2, step 3. No, this is not math at all. Math means language. Okay? So you can express yourself to solve the problem. Okay? So I can solve the same problem totally different than your way. What's the difference? It's the language. Can I learn this language? Sure, you can learn this language. I came here to US with few words, believe me. I started with, hey, my name is Mahmoud. I want to eat. Instead of I'm hungry, okay? So I want to eat. So few words, okay? Today, I can express myself. So I learned the language. Sure, I'm not like William Shakespeare. I'm not in that level, but at least I can express myself. It's the same for mathematics, okay? It's your own language. So if you got the answer by this way, someone got the answer by another way, so it's language. Sometimes I answered a problem with a way, okay, and I posted this lecture. And one more time in the review or problem session, the same problem, but I solved it with another way, okay? At that time, I used my language, which popped up in my head, okay? And someone told me, oh, you did it wrong. Why I did it wrong? Because you did it like this last time. No, it's the language, okay? So take it from the language view. Make sense? If you talk math as language, it's your way, your own way to express. So this is gonna be the best way, okay? Whatever that. So we have many levels for the language, okay? Perfect. Second point was
Formulas?
formulas. Okay, in case of formulas, never ever memorize any formula. Okay, never ever. Why? Because in physics, if you depend on your memory, means that it's gonna lead you to a mistake for sure. Okay, so what's the solution? There is something called formula sheet or equation sheet. You have to go to this reference. In the bigger scale, it is index after the books, or there are some books as index. So you have to go back to those formula sheets. Make sense? Never ever depend on your memory. Okay? How to pick the right equation? This is the skills, and during this class, we will get these skills. How to pick the right equation for this scientific problem. Okay? Perfect. Awesome. Did I answer your question?
Yes.
Okay. My lady. Oh, okay. Start from here? Okay.
I'm not good at math.
Okay.
And I cannot usually only do it if I have a formula. If you give me something different, I'm not very good at figuring it out.
Oh, okay. So yeah, this is very, very normal. Every single one. Me too, by the way. Yeah. So there is a way, steps to find those formulas. Okay. Do you think that I'm gonna read the problem, tuck, I'm gonna solve it like this? Sure not. If I did this, means that I don't understand the physics. So there is a steps, 5 steps to get the right answer. Okay? How to get this? By practicing. Practice, you will find yourself get 100%, not 99%, 100% in the exam. Okay? Perfect. My lady, my friend.
I think my biggest thing is how you have to like visualize the problem in your head and then go from
Oh,
the
no,
words that you-
no. the first lesson I was like you, and you know, when you, if you told me a equation, I'm gonna close my eyes and see the equation as a graph. And I went to my professor, and I told him this, I'm a talented guy, okay? So guess what? He told me what stupidity is that. So he described this as a stupid, okay? And I realized that at that time I shocked and I was really angry from him, but later I realized that he was 100% right. So don't visualize anything in your head. Put it, visualize in front of you on a paper.
I know that, but I mean, like, when you read a word problem, you have to pick apart parts to make the picture to get started before you can do anything else. That's my biggest problem, is that first step.
It's-
If you read it,
Yep.
pick all those things out, make the picture, and then start working through that and figuring out what you have to find. That's
Yeah,
like my
so
biggest
do
step.
you agree with me that this is skills? So you have to practice on this. You described the right way to solve a scientific problem. But this is by practicing. So if you practice on this, believe me, any problem gonna be really easy for you. Okay, and one day, by the way, I'm gonna tell you that you got 100% in the exam.
That would be wonderful.
Yep, because you are really smart. You have a good startup, really. I'm serious, okay? I can see it now. Perfect. So, my friends, and the last thing here, did you notice that this picture represents how difficult is physics? Yes or no?
Yeah.
Okay, and big surprise that this is chemistry. This is not physics at all. Okay? Physics is way easier than that. Okay? Perfect. Awesome. And let's watch this video, please, about this physics course.
Many students think physics is complicated and difficult and not for everyone. They think it's a course that you should avoid if you can, a course that will put you in a world of hurt if you can't. In short, many students fear physics. Now, if you count yourself in this group, I'm here to tell you there's a different way. If you join us in our course, you will join a course that uses the best tools and techniques to help nearly everyone learn physics well. You will stop being afraid of physics. Instead, you will learn how to make physics afraid of you. Now, one of the best ways to learn physics is to do physics. In this course, we focus on that part of physics called mechanics, the science of motion.
So this is physics 1 here, and we will focus on the science of motion, which is scientifically called mechanics. Okay, my friends? Perfect. So this leads us to the question, what is physics? Okay, so let's see this animation describe the physics for us.
What is physics? Physics is the branch of science which studies all acknowledged physical objects and their behavior in the universe. Physics uses concepts and equations to make predictions. Physics is often divided into subcategories. Mechanics studies the properties of motion. Wave phenomena studies the properties of simple harmonic motion. Thermodynamics studies the properties of heat. Optics studies the properties of light. Electromagnetism studies the properties of electricity and magnetism. Relativity studies the properties of space and time. And quantum mechanics studies the properties of atoms.
So we have subcategories here, my friends. The first two, mechanics and wave phenomena, this is called physics 1. Thermodynamics, optics, and electromagnetism, this is called physics 2. Relativity and quantum mechanics, this is physics 3. or some universities called modern physics. Okay? Perfect. Any question? Awesome.
Galileo developed many ideas on mechanics, optics, and wave phenomena using what is now known as the scientific method of inquiry.
Okay. Today, we went to the same direction. So many scientists gonna make like a group, and this group is from different branches, and they're gonna cooperate together in a scientific research. Earlier, it was like every single one is specialized in a specific point, and he gonna make this research in this point only. Okay. Today, we went back to different branches.
In order to follow the scientific method, all scientists must study problems in an organized manner, make an educated guess or hypothesis as to why things happen, test their ideas, collect data, analyze the results, and draw a conclusion.
This is actually, any scientist should do this.
When several hypotheses have been successfully tested, they may become scientific theory or a reasonable explanation of observed events that are related. When the theory is used to predict new phenomena, then it may, over time, become what is called a scientific law. But, of course, this usually happens only after all those who disagree have died.
Very true. So, my friends, the answer of what is physics, so it will be, the answer here is really wide range of answer, and it's going to be differ from scientist to or physicist to another physicist. So, as a general, physics is a study of motion, energy, particles, and matter interactions. Physics describes processes and phenomena in the universe mathematically, so we're going to use the math language here. Physics based on the scientific methods. Here, this is my own view of physics. So this is belong to Mahmoud. Okay, this is my opinion. In simple terms, physics can be defined as the study of energy. So I believe it is study of energy. Okay, someone else may be gonna say, no, Mahmoud, I disagree with you. Okay, I have to respect his opinion. Okay, perfect. So physics is the study of energy. So there are 5 main branches in physics. Each branch represents a different form of energy. Let me see this. So for the mechanics or motion, we have mechanical energy, motion as mechanical energy. Acoustic or sound, this is sound energy. Thermodynamics or heat, so we have thermal energy. Optics is the study of light, and light, you know, it's energy. Electricity and magnetism, so for sure it is also electromagnetic radiation or energy. So in my opinion, physics is study of energy. Also, we can see physics in this beautiful car. I wish this is my car, okay? But unfortunately not. Anyway, this beauty, the physics inside this car, mechanics, so the rotation of this or the spinning of this wheel leads to the motion, mechanics. We hear vibrations and mechanical waves. So we have here shock absorbers, radio speakers, sound insulation from outside. You can also apply physics as thermodynamics. efficient of engines. You can see the optics here is also applicable in this car by headlight and mirrors. Finally, electromagnetism as battery and starter headlights and so on. Okay? And now let's together watch the beauty of physics. I love physics. And look at this beauty. I have here a wheel, rotating wheel. I have here rotating atom. I have here rotating galaxy. And guess what? All of them have the same unique law. Okay? So whatever the case here, it's only one law applied for the three cases here. Okay? Perfect. The coming few slides, my friends, will be focused on the measurements and mathematics. So we're gonna throw some lights on how to measure, and we're gonna throw some lights on some math we needed for this course. Okay? Let me start with the measurements. Measurements is really important, my friends, for the physics. So careful measurements are needed to test explanations. Example here, different theories predict different results. Measurements reveals which theory is correct. For example, motion of cannonball. So the measurement here of this length gonna prove the equations for the projectile motion. So the measurements is really important. And let's start from the beginning here. Quantities. We know that quantity, any quantity, has sign, positive or negative. Magnitude, a number or numerical. Prefix, 10 to the power something. And at the end, unit of this quantity. Prefix, this is optional, so you can use it or not. But for sure, sign or magnitude or units should be used for any quantity, to describe any quantity. Prefix here, 10 to the power something, and in a little bit we will review the prefixes. Okay, now let's see how the measurements is really important in physics. To make quantitative comparison between the law of physics and our experiments, certain basic physical quantities must be measured. Okay, in our course here, Physics 1, we have 3 basic quantities. We have length, mass, and time. Those called the basic quantities. And let me give you example of how those units are really important. If I said Mike measures the length of the room wall with a ruler, he gives us a value of 5. John did the same work, same job, and he gives us the number 16. So now the question mark here, 5 watt and 16 watt, right? So I need a unit for each number here. So those units we will use for this course called SI units. SI units is International System of Units. SI units. It will be for the length, meter, for the mass, kilogram, for the time is second. So we will use those basic quantity units during this course. And let me throw some lights on what is the SI units.
The modern system of measurement, System International d'Unité. The system of measurement used at present originated during the French Revolution. During the period of fast industrialization, need of a common system of unit was felt, so that trade among countries could be easy. In 1875, an international treaty of meter was signed, and an International Bureau of Weights and Measures was established. The International Bureau prepared platinum, iridium rods of special cross-section, which had 2 fine parallel lines engraved on them. The space between these 2 parallel lines was accepted as 1 meter. with scientific development taking place time to time, better and improved unit of length was introduced in 1960 in terms of wavelength of krypton 86. Presently, we use SI. SI stands for the French name Système International d'Unités, which means International System of Units. The SI is maintained by a small agency in Paris, the International Bureau of Weights and Measures, or BIPM, and it is updated every few years by an international conference, the General Conference on Weights and Measures, attended by representatives of all the industrial countries and international scientific and engineering organizations. The physical quantity is represented by a numerical value followed by a unit. For example, mass of a body is represented as 50 kilograms, where 50 is the numerical part and kilogram is the unit of mass. The SI is based on 7 base units, or fundamental quantities, and 2 supplementary quantities. The 7 base units are length, mass, time, electric current, temperature, luminous intensity, amount of substance.
So, in this course, Physics 1, we have only 3 basic quantities: length, mass, and time. If you are willing to go with Physics 2, so we're going to add to them electric current, Coulomb, and temperature, Kelvin.
The plane angle and solid angle are supplementary physical quantities. Go through the table for the SI units and their symbols.
They add those 2 basic quantities, even they are dimensionless. So we have length, meter, and the symbol is M, mass, kilogram, and the symbol is kg, time in second, and the symbol is S.
The 7 base units and 2 supplementary units are not sufficient to meet the growing demands of modern science and technology. So various other units are derived from the 7 base units and are called derived units. Some of the derived units are shown here in the table.
Let me go through the easiest one, density. All of us know that density equal to mass divided by volume. Mass, we know it's in kilogram, so it's going to be kilogram divided by volume. Volume is length times length times length, so it's going to be divided by meter cube. So this is called derived unit. Okay? Perfect. Any question here, my friends? Awesome. Perfect.
Guidelines for SI units. Use uppercase to represent the symbol for a unit named after a scientist.
So if we give a unit as a name of scientist, like Newton, for example, so you have to write it as big N, N capital, okay? Don't make it like N small. Or if you want to write Newton as Newton, you have to write it as N small. Don't make it like N big N, okay? Big N means that this is a name. Small n means that this is a unit. Okay?
Use lowercase to represent a unit not named after a scientist.
Like meter here, for example, meter is not a scientist, so you have to make it like small m.
Do not capitalize the first letter of the expansion of a unit named after a scientist.
We said this before.
Never use plural to represent a unit.
There is no plural for the unit, so kilograms, so it's going to be kg also.
Insert a period or leave space to represent a compound unit formed by multiplication of 2 or more units.
Honestly, I found some of the books wrote it in this way, n directly m after, so it's not like main mistake. Okay, and let me stop here. Perfect. So we have basic quantities in this course, my friends. It will be length, mass, and time. And the units will be meter, kilogram, and second. Okay, friends? Perfect. So now we have different unit systems. We have SI units, this is international. CGS, this is for some countries, like one of them is France. British or American, this is the American units. So someone maybe can ask, Mahmoud, we are in America here and we have to use the American units. If your research is local, so you can use the local units, American units. Okay? Even there are many local institutes, research institutes, they don't use the American units. Okay? So if you are in the research, so you have to go with the international system units. Okay? Perfect. CGS, this is in France, and we said that France has the highest standard institute. So in their research, they have to use the SI units. Even in the public, they are using the CGS units. Okay. By the way, this standard institute in Paris, France, is the top, and every other country it's under its umbrella. The American one here is in Texas. So we have standard institute in Texas. Any other institute, standard institute in America, it's under the Texas one. So the Minnesota one should be under the umbrella of the Texas one. Okay? Agree with me? And this is the same system for every single country. Here for the length, it's meter for SI units, centimeter for CGS units, and for the American, it's inch or foot. Mass is kilogram. For CGS units, it's gram. And it's slug for the American units. Did you see the slug before? It's something very, very tiny, small. Okay? So I didn't see it till last year. It's something very, very small. Okay? And this is the standard unit for the mass in US. Okay? Time is second. Second for all the units. SI units, CGS units, and American units. We have derived units like force. So force, it will be Newton in SI units, and it's equal to kilogram as mass times meter as length divided by second square. In CGS, gonna be, instead of Newton, gonna be dyne, and it's gonna be gram centimeter per second square. And for the American units, it is pounds, and it's equal to slug times foot divided by second square. Speed, meter per second, centimeter per second, and foot per second for the American units. Any question here, my friends? Can I move to the next slide? I will move to the next slide. Let's cover another point we needed for this course is the prefixes. Prefixes means 10 to the power something. So we need to compare between very tiny small, so it's going to be 10 to the power negative thing, and a huge big thing going to be 10 to the power positive number. And let's watch this video.
picnic near the lakeside in Chicago was the start of a lazy afternoon, early one October. We begin with a scene 1 meter wide, which we view from just 1 meter away. Now every 10 seconds we will look from 10 times farther away, and our field of view will be 10 times wider. This square is 10 meters wide, and in 10 seconds the next square will be 10 times as wide. Our picture will center on the picnickers, even after they've been lost to sight. 100 meters wide. The distance a man can run in 10 seconds. Cars crowd the highway. Powerboats lie at their docks. The colorful bleachers are Soldiers Field. This square is 1 kilometer wide, 1,000 meters. The distance a racing car can travel in 10 seconds. We see the great city on the lake shore. 10 to the 4th meters, 10 kilometers. The distance a supersonic airplane can travel in 10 seconds. We see first the rounded end of Lake Michigan, then the whole Great Lake, 10 to the 5th meters. The distance an orbiting satellite covers in 10 seconds. Long parades of clouds, the day's weather in the Middle West. 10 to the 6th, a 1 with 6 zeros, 1,000,000 meters. Soon the Earth will show as a solid sphere. We are able to see the whole Earth now, just over a minute along the journey. The Earth diminishes into the distance, but those background stars are so much farther away that they do not yet appear to move. A line extends at the true speed of light. In 1 second, it half crosses the tilted orbit of the moon. Now we mark a small part of the path in which the Earth moves about the Sun. Now the orbital paths of the neighbor planets, Venus and Mars, then Mercury. Entering our field of view is the glowing center of our solar system, the Sun, followed by the massive outer planets, swinging wide into big orbits. That outer orbit belongs to Pluto. A fringe of a myriad comets too faint to see completes the solar system.
So 10 to the power 13.
10 to the 14th. As the solar system shrinks to one bright point in the distance, our sun is plainly now only one among the stars. Looking back from here, we know 4 southern constellations, still much as they appear from the far side of the Earth. This square is 10 to the 16th meters, 1 light year, not yet out to the next star. Our last 10-second step took us 10 light years further. The next will be 100. Our perspective changes so much in each step now that even the background stars will appear to converge. At last we pass the bright star Arcturus and some stars of the Dipper. Normal but quite unfamiliar stars and clouds of gas surround us as we traverse the Milky Way galaxy. Giant steps carry us into the outskirts of the galaxy. And as we pull away, we begin to see the great flat spiral facing us. The time and path we chose to leave Chicago has brought us out of the galaxy along a course nearly perpendicular to its disk. The 2 little satellite galaxies of our own are the clouds of Magellan, 10 to the 22nd power, a million light years. Groups of galaxies bring a new level of structure to the sea. Glowing points are no longer single stars, but whole galaxies of stars seen as one. We pass the big Virgo cluster of galaxies among many others, 100 million light years out. As we approach the limit of our vision, we pause to start back home.
Anyone want to ask about what's the million light year? Light year? Okay.
This lonely scene, the galaxies like dust, is what most of space looks like. This emptiness is normal. The richness of our own neighborhood is the exception. The trip back to the picnic on the lakefront will be a sped-up version, reducing the distance to the Earth's surface by 1 power of 10 every 2 seconds. In each 2 seconds, we will appear to cover 90% of the remaining distance back to Earth. Notice the alternation between great activity and relative inactivity. A rhythm that will continue all the way to our next goal, a proton in the nucleus of a carbon atom beneath the skin on the hand of a sleeping man at the picnic. Ten to the ninth meters, 10 to the eighth, 7, 6, 5, 4, 3, 2, 1. We are back at our starting point. We slow up at 1 meter, 10 to the 0 power. Now we reduce the distance to our final destination by 90% every 10 seconds, each step much smaller than the one before. At 10 to the minus 2, 1/100th of a meter, 1 centimeter, we approach the surface of the hand. In a few seconds, we'll be entering the skin, crossing layer after layer from the outermost dead cells into a tiny blood vessel within. Skin layers vanish in turn. An outer layer of cells, felty collagen. The capillary containing red blood cells and a rougher lymphocyte. We enter the white cell. Among its vital organelles, the porous wall of the cell nucleus appears. The nucleus within holds the heredity of the man in the coiled coils of DNA. As we close in, we come to the double helix itself, a molecule like a long twisted ladder whose rungs of paired bases spell out twice, in an alphabet of 4 letters, the words of a powerful genetic message. At the atomic scale, the interplay of form and motion becomes more visible. We focus on one commonplace group of 3 hydrogen atoms bonded by electrical forces to a carbon atom. 4 electrons make up the outer shell of the carbon itself. They appear in quantum motion as a swarm of shimmering points. At 10 to the minus 10 meters, 1 angstrom, we find ourselves right among those outer electrons. Now we come upon the 2 inner electrons held in a tighter swarm. As we draw toward the atom's attracting center, we enter upon a vast inner space. At last, the carbon nucleus. So massive and so small. This carbon nucleus is made up of 6 protons and 6 neutrons. We are in the domain of universal modules. There are protons and neutrons in every nucleus, electrons in every atom, atoms bonded into every molecule out to the farthest galaxy. As a single proton fills our scene, we reach the edge of present understanding. Are these some quarks in intense interaction? Our journey has taken us through 40 powers of 10. If now the field is 1 unit, then when we saw many clusters of galaxies together, it was 10 to the 40th, or 1 and 40 zeros.
Okay, this is the difference, my friends, between the prefix as 10 to the power negative or 10 to the power positive number. Okay, this is going to be the last slide here. Here, 10 to the power negative 24, this is called yocto. 10 to the power negative 21, this is called zetto. Mahmoud, do we have to memorize this names? Sure, not. Okay, never ever memorize anything. We said before, memorize leads to mistakes. So don't depend on your memory. Okay, so there is like a table like this, so you can go back to it. To be honest, I don't know any of those except Pico, because I used to go with my research with Pico 10 to the power negative 12 for the time, for the second. So I expanded this time only 1 second, which is thick for us. It's gonna be very huge for me. Okay, so I went to 10 to the power negative 12 of the second to go in the molecules and describe the scenario of the molecules, the interaction between the molecules. Nano, I know the nano. Okay, micro, milli, I know those. Kilo, I know it. Gigabyte, I know it. Okay, terabyte now. but what's beta, what Excel, I don't know about those, okay? Perfect. The last thing before leave, my friends, there is no lab tomorrow, okay? Do you know that? Anyone here think that there is lab tomorrow? Okay, so there is no lab tomorrow. Yes. Okay, perfect. We're gonna start the lab next week, next Wednesday. Yes, ma'am.
Will we have class then or no class?
Tomorrow?
Yeah.
No class tomorrow.
Okay.
So no class tomorrow. So I'm gonna miss you tomorrow. So, but I'm gonna for sure see you on Thursday. Okay. Thank you so much and have a great day. Thank you. You will find this lecture on